Hello everyone. Today we are going to perform an experiment with SR flip-flop. So what is a flip-flop? A flip-flop is the basic building block in any memory system since its output will remain in its state until it is forced to change it by some means. We are going to specifically look at a gated SR flip-flop where states S and R stand for set and reset. There are four input combination possibles at the input, but the state S equal to R equal to 1 is forbidden since the output will be indeterminate. I will be showing you the implementation of SR end to end. To start with the implementation, we would be needing four NAND gates, which is IC number 7400. I'll be connecting VCC ground. So this input is the S's input. The second input goes into the clock. The second NAND gate has R as one input and the second input belongs to the clock. The output of the first NAND gate goes into the input of the next NAND gate. The output of the second NAND gate goes into the output of this NAND gate. There would be a latch that we have to implement. Basically, a latch is such a combination where the output gets fed into an input. For instance, the output of this NAND goes into the input of this particular NAND, and the output of the second NAND goes into the input of the first NAND. So this is what we call a latching. The outputs are then picked up and placed in the output pins as depicted here. Now I'm going to start the simulation. So on mono shorting at input 0 and 1, you can see the value of Q being 0 and Q dash being 1. This state would be retained if I change the input values of S and R to 0. As you can see, the values did not change, which means that state S and R when they are 0 is a memory state. When I change the inputs of S to 1 and R to 0, the output becomes 1, 0. Q becomes 1 and Q dash becomes 0. Now if I go back to 0, 0, it should retain its memory state, which it does. Now state 1, 1 is forbidden in S and R. As you can see, Q is 0 and the complement of Q also is 0, which is obviously not the case. Hence this is a forbidden state because this has to be a complement of this second pin. Thus this is the overall implementation of an SR flip-flop. Thank you.